A scale drawing is a drawing that is a representation of some real life object. So let's have a look at some of these points quickly and then we'll go through some examples together. So what is a scale drawing? So a drawing that represents some real life object is called a scale drawing. So it's obviously drawn to scale in every dimension, of course. When we're thinking about a model car, for example, that's just a small model cars. That's a three-dimensional version of a scale drawing. We're only going to focus at the moment to two-dimensional. Okay, we have something called the scale ratio. Okay, and the scale ratio gives them what we call the multiplication factor of the scale drawing to the real life object. Okay, so we'll look at an example shortly. So, one centimeter on the drawing could represent 1 meter in real life. Okay, that's what we mean by the scale ratio. And scale drawings can represent larger, which tends to be the more common examples that we see, but not always. But they can also represent smaller objects as well than the drawing itself. So you might have a scale drawing of an ant, for example. So it's sort of like it magnifies it to sort of see it and see what it is. But in real life, the object could be quite small. Let's have a look at some examples. Okay. And just before we look at the example, there is one more important point. I just missed this one, that when you talk about ratios, it's not a rate. Okay, so ratios imply that the units of measure have to be the same. Okay, and we'll see that shortly. So let's have a look at example A. Find the actual length of the house given the scale shown. So when we talk about a scale diagram, okay, we assume that everything is to scale, that it's not distorted in any way. So it's stretched too much in one direction, or either in the vertical or the horizontal direction. We're given the scale here is 1 to 150. So what that means is that whatever unit we use to measure, so I could use millimeters, I could use centimeters, I might just use centimeters here. Okay, so the length of the house probably better to say the width of the house. I'm going to change this, sorry. I know it's sort of midway into the video, just to be a bit more precise. Right, let's call it the width. Okay, the length is kind of like, sort of, one could mistake it to be the depth of the house, but anyways, let's call this the width of the house then. Scale is 1 to 150. All right, so we've got 5 centimeters there. All right, so measuring this with a ruler, we've got 5 centimeters. So that means then for every centimeter on this diagram, that represents 150 centimeters in real life. Okay, so 1 centimeter, okay, is equal to 150 centimeters in real life. So what does 5 centimeters represent? Again, think about it. If 1 centimeter is 150, 2 centimeters is 300, 3 centimeters is 450 centimeters in real life, and so on. Okay, so we're going to multiply that by 5, multiply that by 5. Okay, it's like a ratio. So it's 1 to 150. Actually, that's another way I'll write it. Okay, if we multiply that by 5 and that by 5, so it's an equivalent ratio. That's really the ratio 5 to 750. Okay, and that's 750 using the same units of measure, 5 centimeters to 750 centimeters. So the width of the house, right, is equal to 750 centimeters, or if you want to express it in meters, 7.5 meters wide. Okay, so hopefully we can see that from the scale. Let's have a look at some other examples quickly. And part B, express each scale shown below as a ratio. Okay, so the first one, okay, we've just got a scale there. Sort of every mark, okay, represents 5 kilometers. So let's measure that, and we'll see that we've got each of these marks is 2 centimeters apart. Okay, so this is really the scale 2 centimeters. Okay, gives you 5 kilometers. Okay, but the problem we have here is that it's 2 different units of measure. We can't have that. Okay, it's not really a scale ratio unless they are the same units. So I think it's probably best if we keep maybe to centimeters rather than dividing the centimeters down to make it kilometers or to convert it into kilometers. Let's convert the kilometers into centimeters. Okay, so let's convert it into meters first. Okay, so that's equal to 2 centimeters to, well, how many meters in a kilometer? 1,000, so there's going to be 5,000 of those. All right. Now let's convert 5,000 meters into centimeters. So every meter is 100 centimeters. Okay, so hopefully we know our metric unit conversions by now. If not, there's videos there to help you review those. Okay, so we're going to add another 2 more zeros. So now we're using the same unit of measure. However, they're both even numbers, so we can divide them by 2. So we should be simplifying these ratios as well. So that'll be the ratio 1 to 250,000. Okay. So every centimeter on, let's say, a map, or every centimeter on the diagram represents 250,000 centimeters in real life. What about this one? 2 centimeters to 1 meter. Okay. Again, we've got the same issue here that it needs to be converted to the same unit of measure. It's very similar to part I, just sort of to express it a little bit differently there. This one's doesn't need as much conversion or multiple conversions. So 2 centimeters, okay. Well, how many centimeters in a meter? 100, okay. And that's really just the ratio 2 to 50. Sorry, well, 2 to, made a mistake there. Simplified it a little bit too early. I'd just like to show you all the working out. That's 2 to 100, which is 1 to 50. Okay, so 2 centimeters gives you 1 meter, 2 centimeters gives you 100 centimeters. Dividing both of those by 2, you get 1 to 50. So 1 centimeter on the diagram represents 50 centimeters in real life. So that's a multiplication factor of 50. What about this one? Last one, part 3, 1 centimeter to 250 micrometers. All right, just thought, let's use a scale that's sort of in reverse. Okay, and so we're using a sort of a large unit of measure representing something a little bit smaller there. Okay, so maybe we need to convert everything to micrometers. All right, so 10 centimeters, let's convert this to millimeters. 1 centimeter is 10 millimeters. Okay, to 250 micrometers. There's 1,000 micrometers in a millimeter, so we've actually got 10,000 here. All right, converting millimeters to micrometers, we'll multiply it by 1,000. So that's 10,000 micrometers to 250 micrometers. All right, and that's kind of a nice number. You know, if you take 10,000 and you divide it by 250, we should get 40. Okay, so that's really the same as saying 40 micrometers on the diagram is 1 micrometer in real life, in fact. So that could be just written as the ratio 40 to 1. Okay, so 40 units on the diagram, so let's say it was 40 centimeters, okay, for example, represents 1 centimeter in reality.